Okay guys, we are going to start with lesson 2.1.5 and the title is Applying Angle Relationships. All right, so we're going to explore each of these problems one-on-one and see how it's going to help us understand more of the parallel lines and some of the angles that it creates, right? So reminding ourselves of what we learned in the last lesson, what is the sum of the angles between x and y here? So here's your angle x and here's your angle y. What is the sum between those two? Here we have parallel lines, so we have parallel lines this way, and then we have our transversal going down this way. So first of all, we need to recognize that these are interior angles and they are on the same side of the transversal. Therefore, these are same side interior angles, right? So what do we know about same side interior angles? They are supplementary. So the sum of the angles of x and y, x plus y, is equal to 180 degrees, okay, because they are supplementary in that relationship. Okay, all right, now let's continue exploring this idea now, right? So what we're trying to say is, if you know that the angles are going to add up to 180, can they not be parallel? So let's see what's wrong with this diagram. So in part B, someone says something is wrong with this diagram. So even though it doesn't look like it, but these lines, because they have arrows at the end of them, they're going to extend out and go on and on and on, right? So because they have arrows, that implies that this line is going to go on and on forever. And same thing with this line, CD is going to go on and on and on forever. Sorry, let me do a better job of this. So CD is going to go on and on and on forever. And notice that if you continue them, they eventually look like 8. They're going to cross, and hence we create a triangle there. Now, that should give you a pause, right? Because if you create a triangle, we know from a previous lesson that the angles in a triangle must add up to 180. But I already have 100 degrees and I already have 80 degrees. So that means I can have nothing here. It's 0 degrees here. But clearly you see there's some degree there because it has to make a triangle. So your two sentences are contradicting each other. You're saying that this is a triangle, it has to add up to 180, but I already have 180 from these two angles. So this cannot happen. That's why something's wrong with this diagram. This means that, can my angles be 180? Yes, they can, but then your lines can't cross each other. Or if the lines must cross each other, then your two angles cannot be 180 because they have to add up to 180 to create that triangle. Okay, so bottom line is, if the lines are going to cross, then it's going to make a triangle larger than the sum of 180 degrees, right? So then, because of this, then your lines have to be parallel. So the lines must be parallel. They cannot cross each other. So if the lines cannot cross each other, then you can keep your 100 and your 80 degrees here. Okay? All right, so again, trying to confirm this idea. So it says, must line FG and HI be parallel? So FG is this line up here, right? F and G. And then HI is this line down here. Must they be parallel? Well, let's see. What are the angles given me? I have 112 and I have 68. So I go 112 plus 68. What do I get? I get 180 degrees. Yes. So because the two angles are same side interior and they add up to 180, then it gives me this parallel relationship. So the answer is yes, they are parallel. And here's the reasoning right here in part B. If the measure of the same side interior angles are supplementary, so they are 180 degrees, then the lines are parallel. Okay, so this is a statement. So if you have the 180 degrees for the same side interior, then you definitely have parallel lines. Okay. So are there other angles that make parallel lines? Yes. Are there other relationships that make parallel lines? Yeah. So let's take a look at number 249 here. This is what we did in the previous lessons as well. Here you have this 80 degree angle and you slide it down and it's the same position here. It's also 80 degrees. What is that relationship called? I believe that it's called corresponding angles. So if my corresponding angles are congruent, I once again have beautiful parallel lines. So why must these lines be parallel? Because I have congruent corresponding angles. That was the second relationship we had. So backtrack just a tiny bit. If you have same side interior that's supplementary, you get parallel lines. If you have corresponding angles that's congruent, you get parallel lines. One last thing, what else can give me parallel lines? I have this beautiful relationship here. These are angles on the inside of my parallel lines, or inside of supposedly parallel lines. So they're on the inside and they're on the opposite side of the transversal. So these are alternate interior angles and they're both 80 degrees, so they're congruent. So if I have congruent alternate interior angles, I also will be given parallel lines as well. So when these things are true, when you have congruent corresponding angles, or if you have congruent alternate interior angles, they both will result in parallel lines. Okay, so that's my conclusion here. If corresponding angles are congruent, then the lines must be parallel. If the measure of alternate interior angles are congruent, then the lines must also be parallel. So there are 3 different ways to prove parallel lines. You have same side interior angles to be supplementary, you have congruent corresponding angles, and you have congruent alternate interior angles. If you have any of those relationships, then you have parallel lines for sure. Okay. All right, so the last piece here says, hey, use the idea we just learned. Can you find the measures of X, Y, and Z? All right. Again, my approach may not be the same as your approach, and that's totally okay. As long as you are, you're getting the same answers, it's totally okay. All right. So first thing I'm going to see is I'm going to tackle the small triangle here. I have a small triangle here. And I know that these two are congruent sides. And so if I recall what Ms. Chu said a couple lessons ago, that means that these 2 angles are exactly the same. So I see that there's an X there. That also means this must be X as well. And I know that the angles in a triangle must always add up to 180. So here's my justification. Here's how I say this is true because, right? So the triangle sum says that 28 degrees plus the 2 x's must equal to 180 degrees because in a triangle, we always have 180 degrees. Subtract 28 from both sides, I get 2x equals 152. Divided by 2, x equals 76. So I got x, right? That's what I wanted there. Okay, all right. Then I have the fact that, let's see, I'm going to use a different color so you can see what I'm talking about. I don't have to go in order, so I'm just going to jump to Z because right now I see that Z is right next door to X and they make a straight line right here. So X and Z, angle X and angle Z are linear pairs. Remember, linear pairs means a pair of angles that makes a straight line. That's why it's linear pairs. So you can say X plus Z must equal to 180 because linear pairs implies that they are supplementary. Okay. Now I got X is 76 from the previous problem. So 76 plus Z equals 180. Z must equals 104 degrees. Okay, 104 degrees. Lovely. Okay. Okay, now I have one last angle to find. I need to find Y. So I notice that, hey, they tell me that I have parallel lines here. Right, and I can see that this is a transversal. So again, if it's too confusing, sometimes I suggest students to just kind of draw the picture out. So I see that I have parallel lines. I have a transversal this way. Here's my Y and here's the X. So that way it's a little bit easier for me to see, oh, I actually have corresponding angles here, right? So they're corresponding angles. So X must equal to Y, hence, sorry, not X, I'm looking for Y now. Hence Y is also 76 degrees. Okay, all right. So when you have some time, okay, please take some time to kind of read over the last part of this and methods and meanings, proof by contradiction. It's basically what we did today. We tried to assume something is true and then we went backwards to show that it's not true. It's a little bit tricky, but read through it and just kind of see it for the first time. And don't worry, we'll use this method later on in a different chapter. And so this is just kind of a, hey, you know, have an idea about it. And then we'll definitely go in more depth and definitely go through this idea in depth a little bit later. Okay. All right. That's it. And don't forget to submit your notes for this section when you are done with the video. Okay.